Okay, so for part A, number 3, we're going to be, it says here to draw and sketch a Lewis dot diagram of your newly formed compound. Place in the box below. Okay, so we just made this new ionic compound. Remember, you have your own example. This one is mine. And we're going to do a Lewis dot structure from it. Okay, so from that from crisscrossing, we saw that we have 2 GAs and 3 O's. Okay, so I'm going to go ahead and write that out here, that I have 2 GAs and 3 O's. So 1, 2, 3. Okay, so for the Lewis dot structure, we have to look at the valence electrons that it has. So I'm going to click back at the periodic table here. And I'm going to go ahead and write out the valence electrons because that is what we have to use. The numbers from the valence electrons is how many dots we put around the element. So we're going to look at the 1A, 2A. So this has 1 valence electron. This one has 2. This one has 3, 4, 5, 6, 7, and then 8. So my 2 examples, my 2 atoms that I'm looking at is going to be GA and O. Okay, so GA has 3 valence electrons. So I'm going to come back over here. Remember, you are going to be using your example. So it has 3. You have to do this like a 4-sided clock. Start from one side before you overlap. So 1, 2, 3, 1, 2, 3. Okay, now I'm going to look at my oxygens. My oxygen has 6 valence electrons each. So I'm going to go ahead and do it like a 4-sided clock. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so what happens when you put these atoms together is that your electrons are going to want to go from your metal to your non-metal. So it's going to go from Ga to O. Okay, so remember each atom can hold a max of 8 valence electrons in its outer shell. So I'm going to show you in black that this lonely electron is going to go over here to this one. And then this lonely electron is going to go to this other lonely electron. And then this one is going to go over here. And this one is going to go over here. Okay, so notice if I were to count them, they would each have 8. This lonely electron is going to go over here. Put that dot there. And then this lonely electron is going to go over here. Put that dot there. Okay, so if I were to rewrite it, okay, I would write out 2 GAs, okay. Now I would give them each a positive 3 charge because when an atom loses valence electrons, it gets more positive. So it's going to have a positive 3 charge. Each of them do because they each lost 3 valence electrons. And then you're going to write out your other element. In my case, it's oxygen. And now they have a total of 8. So I'm going to go ahead and put 8 in each one. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to put little parentheses here. Okay, that way we're not confused with the electrons, the valence electrons. All right, so we're not done yet. We have to show how many each of these oxygens, how many valence electrons they each received. Well, they each got 2. That's why there's 2 arrows going to the oxygen. So we're going to put -2 on each of them because they each gained 2 valence electrons. Okay, so that's why Ga has a charge of +3, which we talked about up here. And oxygen has a charge of -2, which we talked about up here. So we can double check like that. So go ahead and do your Lewis dot structure. And don't forget that you are going to be uploading it on the next part on Padlet, okay? So take a screenshot. I'm going to go ahead